All right, this is going on page 63 when we're done. So this is one of the last PowerPoints that I have, and it follows your notes because I typed them both up. Not everything's lined up 100% the same, but it will be obvious where it goes. All right, so we're going to talk about similar polygons. Specifically, similar triangles is what we're interested in right now, but a lot of this just, it applies to all of them. All right, and so, figures that are similar. Similar is what goes in your first blank here. And the similar symbol is a squiggly, like what's on top of the congruent sign, but not with the equal sign, right? So figures that are similar have the same shape, but not necessarily, and that word necessarily is important, but not necessarily the same what? Size. Okay, good. So can figures that are similar have the same size? Yes, because if you're congruent, you are similar. You're a boring kind of similar, but you're similar, right? So that's why it says not necessarily. Also, if you are congruent and you are similar, then that means that everything about you, all the lengths and measurements and stuff are all equal, right? So if you take the similar sign and you put an equal sign underneath it, you get congruence. It's like when it's similar and equal at the same time. All right, so similar polygons. Two polygons are similar. There's a little similar symbol again. If and only if the corresponding angles are congruent. All right, corresponding angles are still congruent because there's 180 degrees in a triangle no matter what, no matter how tiny or how huge it is. Then the corresponding sides are not congruent because that would make them congruent triangles. They're also not similar. Sides can't be similar. That doesn't make any sense. But what do you think goes in that blank? Because similar figures are not new to you. Corresponding sides, what would they have to be in general? Well, if they're congruent, then we've got congruent triangles. It's not congruent. They can't be similar. I literally just said that. Corresponding sides. Do they all change at the same rate? Yes. Okay. So if they all change at the same rate, a different form of the word rate is a ratio, okay? But so when you have two ratios that are equal to each other, what's that called? A proportion. They have to be proportional. That is the word we are looking for there. Okay? So corresponding sides are proportional because we can't have them changing at different rates, right? So you have lines over on the right. I don't have lines, but I'll have up there what goes in your lines. The only way we knew at the beginning to prove triangles congruent was to have all three sets of sides congruent and all three sets of angles congruent. Right now, all we have to be able to prove triangles similar are all three sets of angles being congruent and the three sets of sides being proportional, okay? So we can say here that we know that angle X is congruent to angle A, angle Y is congruent to angle B, this is what goes on those lines, and angle Z is congruent to angle C. Those are my three sets of angles that I know are congruent, so I'm just stating that. And then I've got to look at corresponding sides. Now, I have a couple different ways I can tell what the corresponding sides are. From the angles, okay, the setup of the angles tells me which sides correspond to which. If you know all of the side lengths, all of them, then you can put the biggest with the biggest, the smallest with the smallest. But if you don't know all of them, then you're going to have a really hard time convincing me how you know which one's the biggest and which one's the smallest. Does that make sense? Because then you're just assuming stuff. So, all right. So we're going to look at XY. So XY corresponds to AB. That is the smallest with the smallest, but it's also the sides that are across from the angle with the three little arcs on it. So then that gives me 5/10, which reduces to 1/2. That 1/2 by itself means nothing, right? Because one side by itself can't be proportional. So then I got to look at my second set of sides, and YZ corresponds to BC. That means I get 7/14. What does that reduce to? 1/2. Okay. Now, those two together, those two sets of sides are proportional. That's not enough because all three sets of sides have to be proportional. So I have to put XZ over AC. That gives me 6/12. that reduces to 1/2. Now you can't assume that you're always going to get the same thing. If I got 1/2, 1/2, 1/3, then they're not proportional. Does that make sense? So here I got 1/2, 1/2, 1/2, so it works. And so that I can say, so triangle XYZ is similar to triangle ABC. And just like when we had congruent triangles, the order of the letters matters, just like with similarity. So this tells me that X corresponds to A, Y to B, Z to Z, that sort of thing. Half what of the triangle, though? It's not half the area. It is half the perimeter, and each side length got cut in half, but that's not true for every single set of similar triangles. Okay. Yeah, but you have to be careful. You can't say the triangle is half. That doesn't make any sense because it's not half the area. It is half the perimeter, but that's not really what this has to do with either anyway. So, all right, next part. So we're going to identify the pairs of congruent angles and corresponding sides. So these are the triangles we have. So we're going to start with angle B. What is angle B congruent to? G. Okay, is that something that they told us? No. How do we know that? What's my rule, postulate, theorem, definition? It's not the definition of right angles. All right angles are congruent. It's the right angle congruence theorem. So angle B is congruent to angle G. Angle C is congruent to angle H. That is something that they told us, right? Is angle A congruent to angle J? Yes, and how do I know that? Third angle theorem, yes. Okay, so by the third angle theorem, angle A is congruent to angle J. So I've talked about my 3 sets of congruent angles, and then I'm going to look at the corresponding sides. I know that AB corresponds to JG, so that's going to give me 10/5, which reduces to 2. Then I'm going to look at BC. It corresponds to GH. So that's going to be 6/3, and that reduces to 2. Then I'm going to look at AC over JH. That is 11.6 over 5.8. Now I can't just assume that it's 2 because the other 2 work, because they won't always necessarily work. Instead of stressing out over decimals, if you just move the decimal place over once on both of them, you're going to get 116 over 58. Does that make your brain hurt a little less? What's 116 divided by 58? 2. It's the exact same thing as the decimal. It's all about how you presume it. But y'all got to stop this crazy scratch work everywhere. There's no need to go divide decimals. You get 2. All right, so since all 3 sets of angles are congruent and all 3 sets of sides are proportional, are these triangles similar? Yes. Okay, it takes all of that. Just because you can look at it and know that they're all 2, or on the first one, look at it and just know that they're all 1/2. Looking at it and knowing doesn't mean anything. You have to be able to write it down and justify it. Okay, so the next thing we have is a similarity ratio. A similarity ratio is different than a scale factor. You use scale factors when you were talking about dilations. These are not the same thing. These are not difficult by any means, but a lot of people get them wrong because they get them upside down because they don't listen to what I'm saying. Okay, so the similarity ratio is the ratio of the lengths of corresponding sides of 2 similar polygons. Well, these are similar. They're both equilateral, which means all the sides correspond. But then there's 2 things down there. It says the similarity ratio of triangle ABC to DEF, and then the similarity ratio of triangle DEF to ABC. Those are 2 completely different things. And if you don't know how to read those sentences, you're likely to get them wrong. It's asking you for a ratio. Ratio implies fraction, right? So I'm having a fraction. And then when you read this along here, ABC to DEF, that's whatever comes first goes in the numerator. So the similarity ratio of ABC to DEF is 3/6, which reduces to what? 1/2. Similarity ratio of DEF to ABC is 6/3, which reduces to 2. So if the answer is 2/3 and you put 3/2, you say, oh, but miss, I just put it upside down. Well, yeah, you're also completely wrong, okay? Because the way in which it goes matters. That's different than a scale factor, because the scale factors would be the opposite of these. Yes? Is the numerator always when you read sentences? So just ABC to DEF. The scale factor is 2, but the similarity ratio is 1/2. Okay, we good? All right, I'll take that as yes. So then it says triangle MLJ is similar to triangle, or is it? This is a question. So again, they're not always going to work. If so, write the similarity ratio and a similarity statement. So a similarity statement is a statement about similarity, just like a congruence statement is a statement about congruence. Keep that in mind. All right, so I'm going to look at, I'm going to identify the pairs of angles, congruent angles. What is angle N congruent to? Angle M. How do we know that? Not triangles. No, no. All right angles are congruent. All right triangles are absolutely not congruent. Angle L is congruent to angle P. They just told me that, right? What is angle S congruent to? J. Why? Third angle theorem. All right, and then I'm going to compare the corresponding sides. So we're going to start with LJ. So LJ corresponds to PS, so that's going to give me 75 over 30. Okay, so we're going to reduce this. We are not doing any crazy division and scratch work all over the place. Little bit at a time here. Are they both even numbers? No, they absolutely are not, which means I can divide by 2. Are they both divisible by 5? Yes. Okay, so how many times does 5 go into 75? 15. And 5 goes into 36. So now I'm at 15 over 6. Can I reduce that? Yes, they're both, and you can write it down. I can't write here, but 15 over 6 reduces to 5 over 2, right? Can I also, are both of these divisible by 3 from the beginning? Yes, so I could have done 25 over 10, which then would give me 5 over 2, right? First thing, third period, somebody said 15 before I could even ask the question. So 15 does divide into both of these. That's probably not the first thing that pops in most of your minds, right? And that's okay. Just like when you were simplifying square roots. When you're reducing fractions, it's really not worth your time to sit there and try and figure out the biggest number to divide, because you're probably going to spend more time doing that than if you just started simple. So if you don't just know that it's 15, then I would say start with 5 or start with 3 and then do it in steps and get there in the end. Even if it divides out completely and you don't have a fraction in the end, you can still reduce that way to get your answer, and you don't have crazy long division and scratch work that ends up being wrong and unreadable anyway. All right, so this does reduce to 5 halves. Then we are going to do the length of LM over the length of PN. And notice I'm staying consistent. I didn't necessarily have to start with the left-hand one. I mean, it is asking me about that, so it's going to help me to do that. But if I do left over right, I have to continue with left over right all the way down. So this gives me 60 over 24. What are those both divisible by? 2. Okay, so that would give me 30 over 12. And then 6, so then that would give me 5 over 2, right? Or I could start by 6 here. I could start by, there's a lot of different things you could do. You could start with 12. You don't have to start with a prime number, but whatever you see first, I'd say just go with that. It's going to make it much easier on you. And the more you do it, the quicker all that stuff gets anyway. So it's 5 over 2. Then JM over SN gives me 45 over 18. What's the first thing that pops in your mind here that would divide by? 2 is not going to work, but 9 will work, and then it'll be 5 over 2 again. So they happen to all be the same. Remember, all 3 of these, you have to get all 3 of them, and you have to show where it came from. You can't just look at the picture and write down the answer. It doesn't work that way. So now that I've said that all 3 sets of angles are congruent, all 3 sets of sides are proportional, then I can say that the triangles are similar. Oops, well, I gave away my answer. So the similarity ratio, what's the similarity ratio? 5 over 2. You already found it. It's not anything you have to go back and find. That's what you found when you're trying to see if they're proportional. Does that make sense? So it's already there. It's 5 over 2. And then this is how the triangle's named. That's not how it's named in the question. Is it the same thing? Does L correspond to P? Yes. M correspond to N? Yes. So it is. Now, if I had written triangle MLJ is similar to triangle SPN, that's wrong because we're not talking about the same thing, right? Because the corresponding pieces matter. So I mixed up the letters, but it means the same thing. Okay. We all good on that? Easy enough? So it's mainly just explaining, stating stuff as you go through. Right. Like you have to have all of this stuff there. But when it says write the similarity ratio and the similarity statement, this is your similarity ratio, and then this is your similarity statement because it's a statement about similarity. Yeah. But the rest of it has to be there to back up what you're saying. Okay. Anything else? No, not necessarily. I think on the homework, I think there's blanks like that, just like there was blanks kind of here. But no, it wouldn't necessarily have to be in a complete sentence. good question. Anything else? All right, so then I've got these two rectangles, and it says it says rectangle DEFG is similar to rectangle HJKL. What is the length of HJ? Okay, so what does HJ correspond to? Does it correspond to DG? You absolutely have a way to know. Right, so my question was, does HJ correspond to DG? No. Okay, and you're right, your argument was right, you look at the names, but your answer was wrong. The answer is no, because it says right here, DE corresponds to HJ, right? So HJ goes with DE, not with DG, just because it's on the side. And you can't go by the way it looks either. I kind of wish now that I had drawn these so they looked more like squares. So you couldn't just think you're doing the longest with the longest, that sort of thing. So it didn't work that way. But you also have to be careful not to think that's just they're all in the same position. All right, so I know what my corresponding pieces are. I know that DE corresponds to HJ. Well, I have information for DE right here, right? Then DG is my other piece of information on the left. What does DG correspond to? LH, okay? So I'm going to set up my little proportion. DE corresponds to HJ, and then DG corresponds to HL. And since they're telling me that they're similar, they have to be proportional. Now, if I had started with HJ on the top instead of DE, that's okay. You just have to be consistent. If I started and I did left over right, the second fraction has to be left over right. Y'all been doing proportions forever. You've been doing similar figures, so this is not brand new to you, I know. But those little things like that, you not being consistent, sometimes just throws you off. All right, so then I'm going to label HJ as X, so I don't have to call it HJ in my work. I'd rather not. And then I'm going to plug in what I have. So I have 40 over X equals 27 over 18. And then I want you to listen very carefully to the words that are going to come out of my mouth, which I have said at least 5 million times so far this school year. First step, zero work, plug it in, write it down, okay? I cannot stress that enough. Those people that just completely ignore all that when they started working on third period were getting all lost and confused on stuff because they weren't multiplying things right, because they weren't listening to what I was saying. First step, zero work, which is what I do every single time. Do not try and cross multiply in your head and write the answer down in the next step. You need to write down what you're doing because they're not all this easy, right? There's a method to my madness. So when you're writing it down, you're like, I don't know why she's making us do this. This is so stupid. I can do it in my head. That's because you can't do them all in your head. And if you're doing it on the easy ones, then when you get to the more difficult ones, you're just going to be fine with what you're doing. You won't even notice that they get any harder. Does that make sense to you? So I know that in the past, you might have been able to just multiply these two, divide by that, give an answer, and you showed no work. Those days are over because this is an easy one, and when you start throwing binomials and stuff in there, it doesn't work that way, okay? So I'm going to cross multiply. I'm going to multiply 40 times 18, and I'm going to write that down. 40 times 18. See? Bam. I didn't actually multiply it. What are you doing? 40 times 18. Equals 27 times x. Now, there's different ways to approach a proportion. You can treat it like an equation. That's just how this one was done. When you're doing the multiplication and they're just two numbers like this, use parentheses, or you can use the little dot for times. That's fine if there's just one term. Don't use an x. I saw somebody earlier today using an x for multiplication. No, you're going to confuse yourself and think it's a variable at some point. Don't do that. We're way past that. All right, so now I need to actually multiply this. And yeah, it's 40 times 18, but I can really think of it as 4. Anytime you multiply something by 4, all you have to do is double it and then double it again. So what's 2 times 18? 36. And then if I double 36, what do I get? 72. That means that 4 times 18 is 72. Does that make sense? But I don't really want 4. I want 40, so I just stick a 0 on it, and I've got 720. And you see how you think through that? Now, there are times when I'm doing those things that along the way, I might jot down what those numbers were I had in my head so I don't forget what the number just was if I get distracted or if it gets too much stuff, you know. But it's still not me going off to the side and doing multiplication of 40 times 18, right? Again, I'm not saying that you can't ever do scratch work. What I'm saying is some of you need to learn to cut back on that because that's kind of all you have all over the place, and it's just too much for yourself. You're stressing yourself out over that. So this gives me 720 equals 27x, right? So I've got to get x by itself, so I just divide both sides by 27. Now again, no crazy long division, because at this point you probably don't even know if it divides evenly. Maybe it does, maybe it doesn't, we don't even care. You treat it like a fraction, a simple fraction. Are they both even numbers? No, so I can't start with 2. Are they both divisible by 3? Yes. Okay, and I know that because I can add 7 and 2, I get 9, right? So 3 goes into 7 how many times? Twice, with 1 left over, and then 3 goes into 12 4 times, right? And here's where if I could write, I'd actually written in my 2, then and then my 4 and my 0. So I'd get 240. Does that make sense? Okay. And then how many times does 3 go into 27? 9. So that gives me 240 over 9, right? Then can I reduce that more? Yes, they're still both divisible by 3, right? So 3 goes into 240 how many times? 80, and goes into 9 3 times. So I get 80 over 3. Can I reduce it any more? No. Do I want a mixed number? No. Do I want a decimal? No. Do both of those require more work past this? Yes. So I don't know why you're so obsessed with doing it. And one of the reasons that I know that you are is because instead of doing things this way, which is way easier, you try and do long division and then do something with the remainder. No. Stop doing that. You are making your life way more harder than it needs to be. Way more harder. That's not really a word, but whatever. You know what I mean. All right, so do I just box my 80 over 3 and move on? No, I got to answer the question. It's the length of HJ. So length of HJ equals 80 over 3 inches, because I have inches there. That has answered my question, and I'm done. Okay. Questions about that? Yes, ma'am. You can. Most people just don't. You absolutely can. That's a good question. Why can't I? She said, why can't I just simplify 27 over 18? You absolutely can. Most people, though, especially those that hate fractions, don't even think to do that at the beginning. But yes, that's fine too. It's actually way better. It's just not what most of everybody would do. No, that's 100% wrong. What you were saying right now. You absolutely cannot do that. That is how you reduce fractions, when you multiply them. But that is why I'm saying you have to make sure you know the difference between cross-multiplying and multiplying fractions. Those live in 2 completely different worlds, and you cannot reduce them that way. No. That will get you the wrong answer real quick. Okay. Anything else? All right, good deal. You can go ahead and glue that in.